Okay, so in this problem, we're going to look at how to use the input processing output model of problem solving to solve a quadratic math problem, right? So in grade 10 math, you learn about quadratic functions, and you learn how to factor, and you learn about the different forms of the quadratic. So there's kind of the factored form, there's the vertex form, and then there's the standard form of the quadratic. So in this one, I want to be able to say have the user or have my program convert factored form quadratics to standard form quadratics. So if you don't remember, factored form would look something like this. So say 2x plus 5 or 3x plus 7. So that's kind of the factored form of the quadratic. Now, obviously, sometimes there's negatives thrown in there. There might not be a one of the terms that would still be a quadratic function, but I'm not really concerned about going into like the details of making it work for every single thing, right? Since we're just learning how to do this problem solving process and trying to extract what inputs we need, how to process those inputs, and how to output a nice answer. Okay. So we're going to take the factored form of the quadratic. So in terms of inputs, we don't really have the skills to parse this data the way it would be written. Like if I were to enter it exactly like that, we have no hope right now of extracting the pieces of information that we need, because we need the numbers. Okay. So we got to get all these numbers in. So those are our inputs. Okay. They're going to be integers. Okay. So I think it's best just to ask the user individually for all 4 numbers. Instead of trying to do anything complicated. So for all 4 numbers separately. So I'll need 4 input statements. Okay, I think I spelled that right, separately. All right, so that's kind of what I need for an input. For processing, I've got to think, okay, what do I need to do? I've got to turn it into standard form. So standard form has the general idea of something that looks like this, like y equals ax squared plus bx plus c. Okay, that's what a standard form would look like. So to go from factored form to standard form, I have to expand that binomial, right? So, and if you remember, they usually say that you use the FOIL technique. So first outside, inside, last to do the expansion of the binomial. Expand. Right? So using FOIL. So what would that look like? So 2x plus 5, 3x plus 7. So I do get the first, which would be, 6x squared. So the outside would be 14x, the inside would be a 15x, and then the lasts would be a 5 times 7, which is 35. Okay. So, and then we could collect like terms here, right, in the center all of the time. So 6x squared plus 29x plus 35 would be my standard form of that particular quadratic, right? And there's 3 numbers that we would need to basically get in order to do this output. So we would need the number in front of the x squared, the number in front of the x, and then the constant term. So those are going to be our outputs, okay, for the problem. And what else does it need to do? Okay, I guess we kind of got to figure out, well, I mean, okay, it's one thing to be able to do it by numbers by hand because we're smart people and our brains work well. But how can the computer do this? Because the computer's only going to deal with variables. So I got to represent these inputs with, let's say, the letters A, B, C, and D. Okay, so like A, B, C, and D. So usually what we would do is, if I'm trying to figure this out using the computer, well, I know the process I did in my head. Why don't we do the same process with variables? And then we could come up with a formula for what number goes in front of the x squared, what number goes in front of the x, and what number goes in front of the, or what's the constant term, right? So this is kind of your processing. Right? So I have this quadratic, ax plus b, cx plus d, and let's do it here. So if I multiply the first ones together, it would be ac and then x squared. Okay. And then outsides would be adx, insides would be bcx, and the last would be bd. Okay, so we're concerned with the numbers here. Okay. And again, I got to collect these like terms in the center. So I would have AC x squared plus AD plus BC x plus a BD. Okay. So here are the three numbers that I would need in terms of the variables that I got entered from the keyboard. Right. So this is my A. This is my B, and this is my C. Okay, so that should be pretty straightforward to implement in code. They're just pretty simple formulas based on what variables I'm going to be storing from the user in terms of input. Now, I believe this question also said that it wanted to calculate the coordinates of the vertex of this quadratic as well. All right, so we need to kind of think back to how the heck this works for a quadratic. Now, the way I'm assuming the input is going to be is going to guarantee that there are zeros to this quadratic. So it's either going to open up or open down, but it will cross the x-axis twice. So it kind of something like this. So it may look something like that. The quadratic, or open up the other way. Here's the vertex, right? So the vertex is an x and a y point that we need to calculate. And how it works out is, since the quadratic is symmetrical about its vertex, if I know these points, then the vertex should be halfway in between. Okay, so if I can find the zeros, I can find the vertex. Right? So just a little bit of math knowledge we might need to do in order to solve some of these questions this year. So how do I find the zeros? Well, let's go back to maybe our original question here. So what, the 2x plus 5 and 3x plus 7. 2x plus 5, 3x plus 7. So the zeros are where this quadratic equation is equal to 0. So that would be where 2x plus 5 is equal to 0, and where 3x plus 7 is equal to 0. So x would be minus 5 over 2, and x would be minus 7 over 3, okay, or whatever decimals they happen to work out to. I'm not going to deal with the fractions, okay? So, I mean, it would be pretty easy in this case to output them as fractions, but I don't even need to output them. I just need to output the coordinates of the vertex, and that certainly will not be a fraction that we're going to want to calculate very easily, I don't think. But we could. Now, okay. Now what? So halfway in between, so your x value of the vertex, we'll do that dark blue, will be so halfway in between. So I have to add those two up and divide by 2. Okay, so it's this works out to what, minus 2.5. Okay, So minus 2.5, and this one I believe, so 7 divided by 3 would be like minus 2.3333 repeated. Okay. So it would be minus 2.5 plus minus 2.3333, okay, divided by 2. Okay. So the x value of the vertex would then be minus 2.416 if you used your calculator to figure that out. Okay. And then if you want the y value of the vertex, if you know the x value, then you just plug it back into the equation. So the y value would be, and you could actually at this point use either equation. You could use your original or you could use the one that you calculated. Probably makes sense to use the original just in case you screwed that up. So you would say like 2 times minus 2.416 plus 5 and 3 times minus 2.416 plus 7. All right. And do all of that math, and it would come out to something really small, so minus 0.0417. Okay. So that's how we could figure out the vertex given our factored form. But again, I'm not doing it with numbers, I'm doing it with variables. So let's just see what is going on here. So this is, maybe we'll call this like x1, right? This x2 for variables, right? The negative 5 is a negative b. The 2 is the a, right? So x1 is going to be minus b over a. x2, the 7 is the d, the 3 is the b, so this is minus d over b. Okay, and my x value of my vertex would be x1 plus x2 divided by 2, and then your y value of the vertex is just going to be a x plus b, and then this x is from here, okay, just plugging it back into the original formula, ax plus b, cx plus d. Whew. Okay, so I think that solves it because we have everything that we need in terms of the inputs that the user gives, and we just have to kind of output these in a nice way, right? So it looks like, where's my standard form? So it's going to kind of look like this for my output of the 1, and my vertex needs to output, so it looks like an ordered pair. So like the brackets, the number, comma, another number, and then another bracket, just so it looks proper. Okay, so there's our problem solving. So I mean, it took us a while, right? Like I haven't even coded anything yet, right? And I'm what, 12, 13 minutes into my video here, and I haven't touched my development environment or Python. But now that I have this, I could program this in any language I want, right? So let's load up a Python and get these formulas, and we'll just start typing up the code so you can see, or so we can start to see if it's going to work correctly or not. So I'm back in my Spider IDE, and I can start loading up all of these programs. And we're not going to forget to comment our code now, because every time we write some programs, we should be commenting our code so somebody else who's reading it can figure out what you're doing. So the first thing we're doing is getting the inputs from the keyboard. Right. So I'm going to need 4, right? So, and they're going to be integers. So just copy and paste this code the best we can, I guess, and change our numbers just so it goes quicker. So I need B, C, and D, and we'll let those be our variable names as well. Okay, and now I just need to calculate the A, B, and C values. Right, so I'm going to break the rules, and variables should start with a lowercase letter, but for this kind of, it makes sense the way I wrote it to use the capital letters for these. So A is A times C. B is A times D plus B times C, and C is B times D. All right. Maybe for the standard form. Okay. And now we can calculate the x value of the vertex. Right, so we had to calculate those x1 and x2 values, so minus b divided by a, and x2 was minus d divided by c, and our x value of the vertex is just going to be our x1 plus x2 divided by 2, but I do need brackets around this because I need to do the x1 plus the x2 first. Otherwise, it's just going to divide x2 by 2 first and then add x1. That's going to be wrong. And now I can calculate the y value of the vertex. Okay? If you do the problem solving right ahead of time, the code is easy, right? Like this is taking, what, 2 to 3 minutes to write out this code because I've already done the planning ahead of time. Okay? So it's a times x plus b times c times x plus d. Okay? There's my y value, and now I've just got to output what I need to output. So what do I got? So I'm going to need a y equals, and then I need a x squared. Okay, there's no real way to do the actual superscript, so we'll just use the hat there to represent it. That's good enough. Plus b x plus c. I don't actually need the space there because it's putting a space automatically when I do the comma notation. Okay, so there's my standard form, and now my vertex, let's say it is a bracket. Now these are going to produce decimal numbers, so I'm going to round to my x to maybe 3 decimal spots. And then I'll put a comma, and then round the y to 3 decimal spots as well. And the last bracket. Okay, whew. Let's see how many errors I got when I run this. Okay. All right, let's give that a shot. Okay. So what was my a value? I'll use the one that I just did. So 2 is my a, 5 was my b, 3 was my c, and 7 was my d. Okay, so what do I get? I got 6x squared plus 29x plus 35. Okay, so that's what I'm anticipating getting from the one math example that I did, and a vertex of not minus 2.417. I think I got 416666 in my problem solving, and then the minus 0.042, which was correct based on what on the example I did before. Now, okay, how do I know if I'm right other than rechecking the calculations? Well, in this one, I might be able to use like a graphing calculator to kind of see what's going on. So something maybe like Desmos, because I could enter the factored form, I could enter the standard form, and if it produces the graph on top of each other, I know that I'm right. And Desmos will also grab me the vertex pretty easily there as well. So why don't I pull that up, and we will take a look and see whether that actually is making... Okay, so I've got Desmos pulled up on my web browser here, and let's just start entering what I have. So I had a 2x plus 5 and a 3x plus 7 was my factored form, and hopefully the next blue graph that shows up is just going to show up right over top of that to make sure that I'm right. So was it 6x squared plus 29x plus 35. Okay, yeah, so right on top, that's good. So I know my standard form is correct. Now, if I zoom in, I can grab the rest of the information. So it's going to give me my zeros as well. Okay, so minus 2.5 and minus 2.33. So that's what we were expecting. And then there's my vertex. So minus 2.4167 or minus 0.04167. Okay, so I think that pretty much qualifies as we have evaluated that program nicely for that particular input, and it appears to be working correctly. Now, what you might want to do is do a couple other ones as well, maybe to test whether making sure these, like if you had negative numbers thrown in there, is that going to produce the correct results? So when you're testing programs, you kind of want to get like all the different kind of possibilities that could make your program wrong. Like try to break it, right? Try to put in things that you might expect to not work, and when they do work, then you can be pretty confident that your program is correct. In terms of what you should hand in, like any type of, so you need to hand in evidence that you've done that input processing output thought process there. So like you should be doing it on a piece of paper probably ahead of time, or you could type it in on a Word document. But remember, you're doing it beforehand, right? So whatever rough scratch notes, take a picture that of whatever you have for that and submit that as your evidence. You could screenshot a graph like this along with your program output to show that it is working correctly, right? So you need to provide evidence that you've done the IPO process and that you have evaluated your program, along with presenting me with your Python solution, and it has to be commented. Okay, so all those things need to be in there when we do problem solving assignments. Normally I won't make you do it for every single question, or at least not hand it in for every single question. But it's going to be clearly indicated to you on my assignments what things you have to do. And when I'm talking about IPO, this is what I'm talking about doing. And maybe one other thing to keep in mind, well, especially with this type of program, if we were to run it with some negatives here, so I'll see if I can get a good solution here. So let's do 5, -3, 4, and -9. Okay, so one thing about our output that you'll notice here is you have this kind of this plus and then a minus. So if any of these like A, B, C calculations turn out to be negative, especially the B and C, you're going to see how like a plus and then a plus and then a minus there, it could show up. There's really nothing I can do about that at this stage of the course. In order to fix that, you would need to understand if statements, and so you'd have to make a decision based on what the value of A, B, and C is, whether you'd want to put the plus there or not in your print statements. And that's just beyond the scope of what I'm wanting to do right now. So this would be an acceptable level solution for this type of problem at this stage of the course.